Are we live? Seems yes. Hello. Can people hear me all right? Good. All right. My laptop's being a bit noisy. I have some uh, noise cancelling plugin on, so hopefully that's going to be all right. So, who is here from Tidal Club? Mies Darrow is Tidal Club represent. So, okay, let's see if I can. So I have this on my phone as well, so I can look at the chat. Let's see if I can get that working, and then I can close this window. And we can get started. All right, I think that's okay. Cool. So here we are. Let's test my chat on the phone. Seems to work. Right. So we've got a few hours to talk about Tidal and digital audio workstations. And so there's quite a few different aspects of this that we can look at over the next hour or two. And I guess I just want to start by saying I haven't really had that much time to prepare for this. And I've also been suffering from really bad hay fever this week. So I'm generally feeling quite like drowsy. So apologies in advance if you hear me like blowing my nose and stuff. It might be a bit gross. But anyway, so I've been using Tidal since around 2014 ish, 2013, 2014. And so, yeah, I've had a bit of time to try and test out different ways of producing music using Tidal. And I guess if you check out my album from last year, so each of these kind of like discs in this album is kind of like representing a progression of different styles and techniques that I've been trying. So like the first tracks that you'll hear, they're just kind of like patterns, pattern studies, not really performing them that much. And then you get all the way through to like Burn, which was like a single from last year, which is much closer to a normal sort of dance track, I guess, in terms of how it's put together. So I'm gonna just try and I guess like expose as much of my experience as possible for you, and hopefully, yeah, I guess I'm hoping that you guys will be able to take some inspiration, see things that you might want to try, and then also, I'd be even more excited to see people doing things that go beyond what I've done and pushing some boundaries even further. That would be really amazing. So I was thinking to start with kind of like looking at multi-track audio, because it's kind of, for me, it was like the first thing that I focused on when trying to start doing music production with Tidal. And I think probably what I'll do is start off in Logic Pro because that's where I sort of started, and that's where I still do quite a bit of production, and that's where I do pretty much all of my live stuff still. So I won't necessarily go like completely in order here of this list, but hopefully we'll, in a roundabout way, we'll cover all of this stuff. So I'm watching the chat. So if at any point you want me to stop and repeat something, or you have a question, or you want to suggest a tangent that we can go down, that's totally fine. And yeah, definitely jump in with questions and that sort of thing. So, and yes, also, I'm just going to kind of assume that, because I don't really know what you've studied in the Tidal Club program, to be honest. So I'm just going to assume very little about what you've been exposed to so far, and hopefully that'll be useful for the largest number of people. So yeah, in terms of multi-track recording and multi-track audio, I think there's the best place to start really is the SuperDirt startup file. So if you're in the Tidal user base documentation, there's a short article about outputting separate audio channels. And so the code that you see here that sets up these different audio channels is part of this SuperDirt startup file. SuperDirt being the plugin that we use. Oh, hey Alex, how's it going? So in the default SuperDirt startup, at the moment, you have these lines which define the kind of like audio channel outputs that are used. Oh, someone was saying, does anyone else only see the top left corner of the screen? I'm sorry, I have no idea why that might be the case. It's probably because I'm really terrible at streaming. Hold on. So, are there any OBS people in the room? Because currently I have this where it says I don't have any crop on, but clearly there is a window crop going on. So yeah, I don't know if I can drag the window. I'm gonna have to do a quick Google, guys. Sorry about this. Try closing your chat window. I'm not really sure what you mean by that. I have this on the chat I'm looking at through my phone separately. Moving the cursor towards the edges, it shows a red line to drag the window. Thanks, Pete. Let's check this link. I think Pete is right. Is there any way to crop manual? Does it help? Click and drag on the window inside OBS and it will show you the red border. I'm not seeing any red border. Enable preview. Oh, now I see the red border. What does this mean? Am I doing this right? I'm just making it smaller. Okay. The window width is longer than my screen. Sorry, this is such a mess. But hopefully that works now. Sorry about that. Right. Let me just wait till this updates. All right. That'll do. So where were we? We were talking about SuperDirt startup. All right. So yeah, as this document says, if you want to output separate. Oh yeah, by the way, there was Pete and Alex and all you guys. Thanks very much for helping solve that problem. So yeah, the three pieces of code that are highlighted here in this document are the number of output bus channels, this array of numbers, which is the separate stereo orbits, and then the arguments passed to SuperDirt itself when it's booted up. And so in practice, what those mean, I'm going to just look at. So this is like a stripped down version of the one that I use, that I've made for you. And I've got a few kind of like presets here that I've used in the past for different multi-channel setups. So what I have at the moment is pretty much the default that you've seen, except on my number of output bus channels, I've got 16 channels. And that means that I can have 8 stereo pairs. So if we look at how that works with SuperDirt, first of all, in the startup, we create the SuperDirt object, and we pass an argument, which is a number, and then S is just the reference to the Super Collider server. But the 2 here, what that means is that you're going to have 2 audio outputs for every orbit, and an orbit is just like the Tidal SuperDirt way of thinking about audio channels, essentially. So if I have an orbit with two channels, I think of that as like a stereo pair. So, in your audio workstation, you might create a track that is a mono track or a stereo track. So, uh, just a simpler way to think about it, um, having two channels per orbit is kind of like having stereo pairs. So then if I've got 16 tracks and two channels per orbit, that means I've got 8 stereo pairs, and that's what this line here is saying. And so this is attached to the function superdirt.start or dirt start, which is this assignment here. So the first argument here is the port number. So when you boot Tidal, once it's finished its boot sequence, it will say, listening on port number, whatever this is. And then the second argument here is your orbits array. And so each element in this array is an orbit. And then the number is the index within those orbits. So because I have 2 channels per orbit and 16 channels, my orbit indexes are going up in twos. So channels 0 and 1, which are part of the first orbit stereo pair, are here, and then we go 2, 4, 6, 8, 10, 12, 14. If I wanted to do something a bit more sophisticated, like 4 channels per orbit, then you would update the indexes in this array as well. So in this case, that's incorrect. So we would have 5 four-way pairs, and so then we'll look in a moment about at what that looks like inside Tidal. Just with this simple one. But before we do that, we need to look at audio devices. So you can see that here I've got my Super Collider audio connected to a device called Super Collider, but actually that's a virtual device that I've created in this software called Loopback. And so Loopback is kind of like Soundflower or Black Hole. It's a virtual audio software. This is a commercial virtual audio software from Amoeba software. And basically what it allows you to do is create virtual audio devices and then choose where the source of that device comes from. So here it could be any of, or Jack as well. You can use Jack for this. This is just really friendly and stable. So that's kind of why I use it. And so in this case, you can see I've actually attached my microphone to this for now so that you can hear me. But essentially all it is we're capturing the output of the Super, yes, I am on Mac. We're just capturing Super Collider output, and then we have the number of channels here that we want to capture. So usually it would just be up to 16, but because I added this microphone, I added another 2 channels for that. You can see that there. And so here you can see that these channels are being output, which means that when I go to my audio workstation, so for example, Logic Pro, I have this virtual audio device, Super Collider. And if I look at the available inputs on this device, in the context of a stereo track, this is a stereo track, you can see that it has all these tracks available. Maybe that's helpful if I zoom in a bit. So you can see that we have all these inputs available, and there's 18 channels, the same as in our audio device. So now we're kind of ready to test this in Tidal. So I have Tidal running, and let's get rid of that. Maybe I should make this font bigger. Oh. Oh, dear. That's way too big. Okay, so I have a pattern which is just for bass drums. And now that this is all set up, I just need to record on these channels. And so, yeah, really new mix. So hopefully you can now see and hear a bass drum coming in through by default, because I've not specified an orbit. It's coming in through the first two channels, and you can see that it's also coming in here through the virtual audio device. So if I now specify an orbit argument, it's going to send this sound to different orbits. And I lost the rhythm from the kick drum. Okay, so one thing you'll notice is that because we've got stereo pairs, if I increment this number, it's actually incrementing the number of channels in the door by 2. So orbit 0 is input tracks 1 and 2. Orbit 1 is input tracks 3 and 4, and so on. So if we do like run 8, then you can see that these sounds are now flying around. All right, so that's very basics of multi-track audio. Does anyone have any questions about this before we move on? Yeah, so you can obviously imagine, you know, if we make these all slightly panned and we imagine that these are in a room, they could be different speakers. Is there added latency with loopback? I haven't noticed any additional latency. Hashtag versus $sign. We'll have to come to that later, I think, when we talk about more Tidal stuff. How do I monitor myself? I've never actually had like a good monitoring setup, but you could definitely do monitoring pretty easily. That's Iris. I hope Iris doesn't think that I speak Spanish, because I don't. But yeah, you could set up some kind of monitoring like a DJ if you want. Yeah, so yeah, you could use GarageBand. You could use anything that has an audio input, yeah, you could use some open source DAW or something like that as well if you wanted to. So, all right, where are we going next? Let's go back to the list. So I'm gonna skip over synchronization because I don't really do synchronization properly with Logic Pro, and we'll come back to that when we get on to Bitwig. But in terms of DAW templates, well, actually, let's do MIDI first. So because that's involving the setup, SuperDirt setup. Okay, so we've just done audio. Obviously, being able to record MIDI as well is really crucial for doing music production, because pretty much everything, software, hardware, speaks MIDI. And if you're unfamiliar with MIDI, it's basically a digital protocol for sending notes and parametric data related to sound that has been around since the 80s. And it's the first sort of standardized protocol for digital communication about music. Before that, we just had control voltages, which were kind of difficult to deal with. And so, yeah, most things today still speak MIDI. So in Tidal, historically, there was a package called Tidal MIDI. And maybe it's useful just to point out the fact that this is now being archived, so it's not supported, and basically it never really worked very well for various reasons. And because we have the powerful super collider that we're already using, eventually the MIDI stuff got moved over to there instead, because MIDI in super collider is extremely stable. So to use MIDI with SuperDirt, essentially the process is that you connect a MIDI device to a synth in Tidal. So in the same way that you have SuperDirt synths and the SuperDirt sound, you know, if you have a synth like Super Piano, then inside SuperDirt there is a synthesizer definition, which listens to messages from Super Piano. So what we're doing with MIDI in Tidal is we're creating a MIDI kind of synth, if you will, and adding that to our SuperDirt library. So I just have a really simple setup for MIDI devices. And again, I'm using for the MIDI out, I'm using a virtual MIDI device. Let's see. Right, so following this documentation. So let's see. So in Super Collider, you need to initialize the MIDI client, and that is going to start up the MIDI system in Super Collider. And when you do that, it's going to enumerate all of your MIDI devices. So I already have it set up, but I'll just do this anyway. Oh, you can see it there actually. So you can see that my boot file actually boots the MIDI as well. And so these are the MIDI devices that I have attached at the moment. I don't have any hardware. What I have are these virtual MIDI drivers. So in my case, being on a Mac, those are handled with the Audio MIDI setup utility. And this allows you to create MIDI devices. So I've got a few different ones here. And so yeah, if you look for if you're on Mac, if you look for the IEC driver, that's where you can set up your virtual MIDI ports. So I've got a couple of them here, one for Bitwig, one for Tidal. And so if we look back over to the startup code, so try that. So basically what we're doing is defining a MIDI output destination, and we're naming that based on the information that Super Collider spits out when you initialize the client. And so in my case, if I want to have a synth called MIDI, which will output MIDI to this virtual MIDI device called Tidal that I've created, then I'm adding to the Super Dirt sound library a MIDI device called MIDI, and it's targeting this Tidal MIDI out. And for me, that refers to this virtual device, and you can set a latency parameter for it as well. So the code that you write in Tidal will correspond to whatever you call this. So for me, I just called it MIDI. You could call it whatever you like. If you have a specific, like, if you have an analog to keys device, then it might look like this. And in Tidal, then you would write, analog keys and so on. So let's see what that looks like in action. So back in Logic, I just have a synth listening on MIDI input. So if I run this, oops. So that's it really, to get a simple bit of MIDI going. And I think that's probably all I'm going to say about that. If you follow this guide in the user base, it goes into more detail about the different MIDI functions. So obviously you can specify different MIDI channels that you want to send on. So yeah, you can send MIDI to different tracks if they're linked up to different channels. You can also send MIDI CC, which is control change. So that's kind of like a message that you might want to send to control a parameter of a synth. So yeah, so if you want to control a synth in Ableton Live with MIDI, yeah, you would just need to set up Ableton Live to listen to that same device. Yeah, so yeah, if you want to send CC values, you can do that quite easily. Here's some examples. There's also some stuff about MIDI clock I don't really use MIDI clock because it's too much for me. So I'm not gonna go into that. But there is some stuff there about MIDI clock. Yeah, I guess the annoying thing about Logic Pro is that you can't dictate what the clock is from externally. Logic doesn't let you do that. It's a very Apple way of doing things, I guess. Cool. All right, and then thinking about like Logic templates specifically. So if I'm just my GitHub link is broken. Which link? Carl, which link are you trying to get to there? So yeah, I'm not sure which GitHub link is broken. But yeah, in terms of DAW templates, I've tried different things over the years, and I think yes. Sorry about that. I forgot that I had that connected there. So yeah, I've got various like templates that I've made over the years, and I guess for live performance, um, what you need to consider mostly is that you don't want to overload your CPU and cause a crash on your machine. So I actually go with a very simple setup. This isn't actually the right one, I don't think, but I'm not going to change it because then my microphone will disappear again. But essentially, it's not too different to this. I just have like for each of my inputs, I just have like a like basically kind of like safety rails to make sure I don't blow up any speakers or hurt anyone's ears. So, for example, you can put a high cut and a low cut on the input channels just to make sure nothing crazy happens. And then if you want, you can do a bit of compression and limiting. Again, just to hold that maximum volume. And then again, you'll probably want some limiting on the final output as well. There's this quite cool free limiter that emulates like one of the Waves plugin limiters called W1 limiter. I think if you look up George Young's W1 limiter, you can find this free plugin. It's pretty good, just for like a really raw, loud sound. So I think the only other thing that I have is worth mentioning is I just have these channels grouped into a little folder, as you can see, and I have that whole stack running through just a really basic reverb that's not got a very long tail. So maybe I can let's see if I can just show how that sounds. I'll just turn my mic up for a sec. So I hope that wasn't so quiet that you couldn't hear it. But basically, it's just a really small, short reverb on everything with a low cut. And all it does is just add a little bit of ambience to everything. So your channels are all going through that one short reverb, and it's just kind of gluing things together a little bit. You can do more elaborate stuff, like if you know, for example, that you will only ever send bass sounds or kick drums through this track, and you will only send synths through this track, and you only send vocals through this track, then you can be a bit more sophisticated about how you kind of mix your live sound, and obviously that's closer to what people usually do in a multi-track context, is separate different instruments into different tracks. The reason I don't do that is because if I'm doing stuff in Tidal, I find it really easy to forget which sound is being output to which orbit. And when you have some more complex code, like for example, let's say I have a track like this, and I'm like introducing tracks. I mean, I can probably run it. Should work. No. Oh, I don't know why it's not. That's fine. Oh, it's because I've now got those samples. So I don't have those samples connected, that's why I didn't play, but you can probably see, like, if I've got this whole bit of code running, and I'm trying to like change something on the fly, all I don't want to have to do is look up like which track it's being sent to and make sure that I'm allowed to write that piece of code on that track. So like this second pattern here has like a kick and a clap. So if you're trying to like improvise or do something on the fly, I find it's pretty constraining if you have to change what you write based on what the orbit is, and if you suddenly have to change all the orbits in order to make a change in your code, then you're kind of stuck. by that point. So that's the reason why I don't go into that much detail with like producing a live mix. So there's probably like, yeah, there's obviously a lot more you can do to make your live production sound better, but there's these two problems really. One is you don't want to you want to save your CPU for Super Collider, number one, and number two, if you overcomplicate the way that you use the orbits and make them specific to each channel, it kind of dictates how you write your Tidal code. So it could, if you're really particular about how you want to produce your live sound, then that's probably something you want to look at. But for me, I just like to have the flexibility. So yeah, I think at this point I'm ready to leave Logic and go over to Bitwig and look at synchronization and so on. Yeah, how's everyone doing? Does anyone have any questions or want to go back over any of those topics or ask any sort of Logic Pro specific questions? Thumbs up. The only other thing I'll mention is that you can sometimes afford to have like a much bigger buffer size when you're doing live coding stuff, because um, that latency doesn't necessarily matter too much, because there's a fixed delay anyway between like hearing the pattern after you've executed anyway, that's longer than the buffer size anyway. So you can get away typically with like higher buffer sizes, which can be good for like if you for live, if you're worried about your laptop. So you do or don't record in separated channels by others. Yes. So yeah, so maybe just to make this abundantly clear. So if we do a little recording now, and I'll just go back to this bit of code. Oh no, I think SuperCloud is unhappy. Let's hope you can hear the birds. There we go. So it's Logic, I think. Hold on. There we go. Okay, so if I set this recording now, I'm going to record myself. All right, so hopefully, Toro Tombo, hopefully that makes it clear. So in this pattern, we're cycling around the different orbits, and those are arriving on different input channels, like so. Beautiful. Beautiful. And if you had the MIDI going at the same time, then that would also be recorded in. Do I have a specific workflow with Logic other than using it to mix live? Yeah, so I think, yeah, I think that's one that I'll come back to because, yeah, I have definitely have workflows around like producing tracks that I want to discuss. So it's a little bit in a mixed order because I need to swap over to Bitwig at some point, but maybe we can do a bit of this now. So talking about like more like production rather than live stuff. So I think the main thing to say is that I've never found one way of doing things that is like perfect, and every time I do produce a track, it always ends up being something different happening. So sometimes you start something in a DAW and then you export some part of it to a sample pack so that you can live code it and record it back in. That's one thing that I've done before. I guess more typically, you know, you have something that you quite like in Tidal, and then you want to, yeah, do something with it in Logic. So that's the point where it kind of gets a little bit interesting because what I usually find is that if I have a track in Tidal, and let's see if I can actually find one where I have all of the tracks available. I'm gonna need to re-include new note. Gonna need to load some other sound files and boot. Come on. Let's see if it just works. There we go. So let's say I was looking at producing this into a demo. So I guess the problem is that when you have title code, you don't have like a temporal view of it, right? So in a DAW you have time represented, and everything is based around moving things around in time, and like that's the opposite of what you have in Tidal. You just have little bits of time but then you're transforming them in different ways, and so those transformations are happening across like non-repeating loops. What is glow? Yeah, sorry. This is all written using my like shorthand, which is part of my library. And so I am planning to like go into that a bit as well. So yes, I will try and explain that. But yeah, so I think the problem is like you can't really see the track, right? Like you can see a track when it's in a multi-track context. So you have like different ways of approaching that problem. And so one way to approach it is that you kind of you treat this as like an instrument that you learn how to play this song using this code, and then you try and do like a perfect take, and you record that take into your multi-track, and then you try and like just tidy it up. So that can work if it's obvious what the structure of your track should be. But the problem is it's not always obvious what the structure of your track should be when it's just code in Tidal. And actually, when you're making a track in an audio workstation, it's laying it out in time and then messing with it that helps you understand the structure of the music. But you don't really have that here, as I was saying. So yeah, some tracks that I've done were done in this like one take fashion, and one of those is Burn. So that was like a single for which there is a video. So Burn is just one take and pretty much no post-production, just a bit of like mixing. So, but that's kind of like rare, I think, to have the whole track figured out ahead of time. And so if you don't have the track figured out and you know exactly what what it should be in your audio workstation, then you also then have to make a few other decisions. And so what my general strategy is there is to basically kind of like sketch out what you think you know so far about what the track should be. So like let's say with this track, right? So this is probably what I would do to kick off the production of this track. Okay, so that was kind of uh, a pretty bad jam. But the idea is, um, you're recording out all the different ideas that you have, and then afterwards you then need to go and cut them up and start arranging in your workstation. Thanks, Alex. And yeah, so I have this little helper function called mix, and yeah, again, I'll go a bit more into the code soon, but just thinking about the production workflow. So what you're trying to do in this case, if you have some code that you like but you don't know what the arrangement should be, you basically just want to like record out for as long as you can be well bothered to, and go through all the different little variations of your code that you think could be interesting for your track, and don't worry and don't worry about like um, doing a good take or something. Like I have maybe I can show. Yeah, so maybe this is helpful. So I have, hold on, I'm gonna wait, no, I can leave it open. So yeah, I'm gonna be archiving this stream so you guys can catch it. And so as an example of what I've just been talking about, let's see. Oh, maybe I don't. Do I have these projects? I think this is. Maybe I don't have it. I think I put it on my hard drive. Okay, well, instead, so I can load up a track that I just finished like last week. I'll just need to re-add the microphone, sorry. Hello. So noisy. Oh no. Hello. Hello. Okay, sorry, there's loads of latency because I've got shitloads of plugins. Um, what I wanted to show. So this is like a finished track, right? Which started in Tidal, and hello, hello. I think it's like, man, it's like pitched me up, and it's hilarious. Hello. Okay. Sorry about that. So yeah, it was crashing because I had too many plugins in that project. Close Google Chrome could be a good idea. I'm gonna lose these tabs. Right, can just grab this. Okay, so what I wanted to show was in that finished track that it was exactly that kind of situation where I had some code which I really liked, but I didn't know how the final track should be in Logic or in an audio workstation. So all I did was like did literally like a 10-15 minute jam of like all those patterns and go through all their different variations. Um, and then after that, I'm kind of like uh, done with Tidal, and then it becomes more of a working in a traditional kind of DAW kind of process. So that was a very long answer to that question, but I think it's useful to know that like there isn't like a correct way to make a track, and actually the more you experiment with like different uh, approaches, the better results you'll get. And also often like you need to just think about the piece of code that you're working with and like think about how much you know about what the end result should be. So if you just have some weird sounds but no structure at all, then that's fine, and you don't need to feel like your code's not good or something. You just need to accept that that's the status of that idea and just record it in and then see what happens. And then sometimes, yeah, you'll know exactly how you want the piece to be just from playing with it in Tidal. Um, but yeah, don't worry if that's not the case, because it's quite rare, and I think that's, as I said, that's a lot to do with the fact that um, that you are working in code where you can't see the timeline of the track. So, all right, so where are we now? Let's see our list. So I've kind of done a bit of music production and live performance stuff, and we've done some logic. So basically, I guess there's two kind of areas still to cover. One is like Bitwig and OSC, and how I'm like developing a new workflow to combine those together. And then the other is more looking at like Tidal itself. So like the library that I use, and yeah, how I generally write Tidal code and how that might be useful for you, and how I guess, yeah, talking about how I learned Tidal as well, in case there's any useful lessons there too. So yeah, I don't know if people have a preference for which one we go with first. Or maybe, okay, someone's saying Bitwig. So this is, so Bitwig, yeah, this is like brand new, and it's so new that I haven't really had time to play with it properly, but it is really interesting. So I'm just gonna quit Logic and get the mic up and running over there. Okay, so hopefully you can hear me again. Got some Bitwig fans. I wish I'd learned Bitwig earlier, but I'm starting to get there a little bit. So let's look at this OSC stuff. So first thing to say is that you need to have the Bitwig OSC. Someone's saying I'm muted. I assume you can hear me, right? Yes, someone's saying they can hear. Okay. So all these tabs, but we do want the page about OSC. All right, so there is a plugin that you need for Bitwig, or an extension they call them, and it's called Driven by Moss because it's made by a guy called Moss. He's a really cool producer and music technologist guy, and he maintains this package which makes Bitwig compatible with tons of controllers and open sound control as well. Um, if you've never seen this before, go and check out his YouTube channel because he has loads of really great videos about how you can control Bitwig in various ways, and his integrations are like really, really deep, which is really interesting, as we'll see. So yeah, so you'll need to have this extension installed. And so actually I have started writing some notes about this, so we can maybe follow that. Oh yes, so let's start here. So let's say you've got your driven by MOS OSC extension set up. It will appear as a controller, and you want to set up your open sound control controller. So you can add controllers in this menu, and the settings that you want are that you want to set your send and receive ports, your OSC ports, um, so that they match the Tidal ports, and you can also set the value resolution. So we were using MIDI before, which has uh, a limited bandwidth, whereas with open sound control you can have a lot more bandwidth because it's just internet protocol. So you can have values that go between 0 and 16,834, which is quite a lot of resolution, which is pretty cool. And then, really important, it will make sense now, but it will make sense later. You want to set this setting bank page size to 200, which is the highest number it will go to. So that's what this looks like here. These are the settings I've just explained. And so now, oh yeah, and also, so this driven by MOS thing has like a, as part of the OSC spec, just to explain how detailed this thing is, it has its own virtual MIDI keyboard that you can address over OSC. So you will need to set up a custom MIDI port for that. So again, going back to the audio MIDI setup in the virtual MIDI driver, I have a port set up for Bitwig OSC input. And that's selected there for MIDI. And it uses that to allow you to send MIDI over OSC, which is pretty cool. So that's the setup that you need on the Bitwig side. And then so all this stuff we've kind of covered a little bit in different ways. Yeah, so I'll leave that for now. Let's go to so actually it probably makes sense to go to my library. So yeah, I have this, I call it a library. It's just a collection of Tidal stuff that I've put online that you can use, and it has some instructions about how to install it. I think the README might be slightly out of date because I've just changed things a lot. But basically, what you can see here is some Tidal and SuperCollider setup, and in particular, it has in the Tidal section um, the OSC target for Bitwig, which is quite a massive thing. So if we go over to here, this is like the main file for the Bitwig integration. And so if we compare this with what it says in the custom OSC documentation, so this is kind of broken into a few different parts. First it says defining a target, which just means like the place that you're sending OSC to. And then defining OSC message structure. So what the OSC paths are that you want to send to. And then finally, like the parameters that you want to call from Tidal in order to send those messages. And then how you turn that into a stream so that you can do like your D1 BD or whatever it is. So the way I've structured this is so maybe, I mean, if we go to the driven by Moss, so this is the OSC protocol that Moss has created for Bitwig, and you can see that it's like, number one, it's massive, and number two, it covers like everything, all the way to like global stuff like undo. You can save projects from OSC, and yeah, so we can do all of this from Tidal, which is pretty insane. So the basic structure is that we have the target, which is just the address, and you'll notice that the port there is the same as the one that we have defined in Bitwig. And we even have like a small range converter built in. You don't need to use this directly, really. I just use this internally, but that allows us to use the full value range, the full resolution, which is great. And then you have this thing called an OSC map, which is basically just like the list of OSC messages. And the way this works is that because it's so big, this OSC spec, I've split it into like different files for each section of the specification. So, you know, there's like global, project, transport, track, and so on. User parameters, scene, virtual keyboard that I was mentioning. So yeah, you can trigger notes in Bitwig from Tidal using OSC, using this virtual keyboard. So if we just look at what those individual files look like, let's collapse these into one window. So for example, global in this OSC specs folder, that's the first one. So each one has a link to the documentation for driven by Moss. And so in this case, maybe we can do that side by side actually again. So global has three things there: pre-roll, undo, and redo. So we have the OSC specs for undo and redo. It has an argument list with nothing in it because it doesn't take any arguments. And then below, these are the parameters that are accessed from Tidal. So I'm not going to go into all of these because it's massive. Like if you just look at the track one, it's all these different OSC addresses, and then loads of like Tidal parameters with constraints on them so it doesn't crash the plugin, and then loads of shortcuts, shortcuts built on shortcuts and utilities. So there's loads of stuff here, and I've not, as I said, I've not even had time to like play with it properly. But what there is this file bitwig.tidal. So if you can get this installed, then basically all you need to do is look through this bitwig.tidal file, and this has examples of Tidal code for like everything that you might want to use, and even some funny stuff down here. So let's have a look. So I have a copy of this. Okay, so I don't have any clips or anything in this project. It's just an empty project, but we should still be able to just look at some basic stuff. So, wait a moment. Oops. So first, oops, I need to actually boot the bitwig target. So yeah, in the library, you can choose which targets are active. So I need to remove that. So where in the documentation where it says, where it gives you a summary, this is just like the whole thing in one short example, but I've kind of split these different parts up into different files. So at the end, what you need is to create an OSC map, which has a tuple, and it's an array of tuples, and in each tuple you have a target and some OSC messages. So in this case, this target is mapped to these OSC messages, and then that gets passed to your stream. So in boot Tidal, like the default boot Tidal, you'll see stream like this, and then you replace that stream. So the cool thing is that you can actually have different bitwig targets working side by side. So I'll show an example of that later, but just for now, I'm going to enable the bitwig OSC map. And then, so I've saved that now. So now when I boot Tidal, it's going to connect to the bitwig target. Okay. So now, all right, so I've got a shortcut bitwig play, and you can see that it started playing bitwig. There's bitwig stop. I've got a hush prime, which will hush Tidal and bitwig, so it will tell bitwig to stop playing, and it will stop the Tidal pattern playing. Bitwig BPM, so you can change the BPM in bitwig, or you can even do like patternable bitwig tempo if you want to do that for some reason, which is quite funny. So the way those work is, let's look at bitwig lib, which has these shortcuts. So for example, bitwig play, it's just once. So once is like means that Tidal message will only get sent once. and then it's using the Bitwig transport parameter to send the message play. So that's how that works. So let's have a look at some of these. So we can change the master volume and pan. I think there's actually a bug in Bitwig with OSC where it doesn't show the parameter updating sometimes. Or maybe is it most so in this case I've not mapped it to the Bitwig OSC range. So there's still some stuff I need to figure out with this. No. Right, so now you can see that I am controlling the master pan and showing it go from left to right there using a range. So that's the master. You can launch scenes. So I'm just going to make some clips, but they're not going to have any information in them, but just to show scene launching. So there it's launching scene 1, you can launch scene 0, scene 2, or obviously you can have a pattern. Of scene launches. You can even create a new scene. So if I run this, it's gonna, I think, yeah, it's duplicating the scene every loop. So it goes on and on. Like you've got everything basically. You can add tracks. You can control track volumes. You can record arm tracks, unrecord arm tracks, change the track send volume. The clip launcher is pretty fun. So if we do like some more, oops. clips. You can do clip select, clip launch, clip record, clip remove. There's clip hush, clip return to arrangement. There's a virtual MIDI keyboard which has polyphonic aftertouch, which is pretty cool. And then do I have? Yeah. So for the clip launcher, I started making these shortcuts called heaps. I don't even think I will be able to explain how it works, but hopefully you'll be able to see how it works. So tracks, and then tracks, and then obviously these could be oh my god, I'm like looping myself. Tracks, and then tracks, and then tracks, and then obviously these could be tracks, and then 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 oh, I don't know why. Must be a bug maybe. Yeah. So sorry. So what I was saying is hopefully you get an idea for what's possible there. And the funny thing is like you can do some really weird stuff like because you can save a project like that actually means you can have like auto save that is just um it's just like a pattern of saves that get sent every X cycles. So I could do autosave every 1 cycles, and you can see that it's just like auto saving in the background. And I have autosave stop, which is pretty funny. You can do undo and redo, which is again just like kind of hilarious. Yeah, and then so the thing that's really wild is that the way that this new Tidal OSC thing is made, you can actually have both targets running at the same time. So you can target SuperDirt and Bitwig from the same stream. So, for example, if I go back to here, and then I just have those together in a list in my OSC map, SuperDirt OSC map and Bitwig OSC map, and then just reboot Tidal. So now I can do stuff like I'm going to delete these stupid recordings of my voice. So now what you can do is you could have like a stack of like normal Super Collider, SuperDirt stuff. Oops, I killed it somehow. Oh, I quit Super Collider. That'll be why. And then basically you can just have this like automatically recording into clips in the background while you're playing. So like you could have what is it? Clip record. I still haven't even like figured this out, but basically you can have a workflow where I'm not even going to be able to like properly do it, but basically you can be doing your Tidal, and then in the background it's incrementing scenes. Maybe I can do it actually with this scene. This is how new this is. I haven't even like tried this properly yet. But like for example, you should be able to do this. Yeah, no, I still haven't really figured it out. But basically, you should be able to automatically record into clips as you're playing. And then you can even like stop the Tidal pattern from playing and then just start coding the clip launcher of the clips that you've just been live coding. So yeah, this really kind of opens up some crazy stuff. And so the question yeah, how do you end up using it? I don't know is the answer. There's just loads of stuff that you can do with this potentially, and it's kind of like it's almost like too big for me to explore on my own. And can you send OSC to SC and Bitwig? Yes, just covered that. Are there latency issues? There could well be. The way it works with latency and is more to do with scheduling. So with the OSC targets, you have 3 different modes of scheduling, and those are explained here. But basically, because I'm using the Bitwig OSC extension, it doesn't have an OSC scheduler, whereas Super Collider will take your Tidal OSC messages and then schedule them. So there probably would be some latency issues, but I'm not even at that stage yet of finding where those pain points are. And then the other question with link, yeah, so Ableton Link. So if you go again to the user base and go on link synchronization, it describes this kind of work in progress integration with Ableton Link using this tool called Carabiner, which is just like it's a command line version of Ableton Link. Yeah, I mean, if you do just script the transport from Tidal, maybe you don't even need Link, but I think you kind of do anyway. I think it's good to use Link. Sending controls to Tidal is okay, but triggering notes is kind of unstable. Yeah, Thomas, I'm not sure if do you mean like using this Bitwig OSC, or do you mean like sending MIDI to Bitwig? So I have a shortcut anyway, obviously already for this, which is just Bitwig link. So yeah, so if you have Carabiner installed, so I have like a shell alias for this. So this is the section here. Yeah, I mean, with Bitwig, you can use the virtual keyboard device built into the OSC, and I have that like in here somewhere. Bitwig, yeah, virtual MIDI keyboard. So you can do that if you want. I'm not tested yet. If it's, I mean, I've played it and it seems fine, but I've not like stress tested it against Super MIDI to see which one is better. But it definitely works. And you have like, as I said, you have like polyphonic aftertouch, which you don't even have in Super Collider. So that's also pretty cool. So yeah, with Carabiner, that's the Ableton Link command line utility. So basically, yeah, is this code which creates the connection. And first you just need to have Carabiner running in the terminal. So I already have that installed. So if I do that, you can see that link icon has a 1 because it's found this. And then basically Tidal doesn't connect directly to Bitwig, it connects to Carabiner. So if I just do Bitwig link, what is it? It's not that, it must be something else. Oh, yeah, so it has 2 arguments. One is the beats per cycle, and the other one is the nudge amount or the latency amount. So if I do that, it should connect. And so we can just prove that that's working by doing like a tempo change from Bitwig. So it is working. So yeah, there's some limitations, like this Carabiner thing is kind of like incomplete in terms of its integration with Tidal, but it does give you a basic sync. So yes, we've been going for like nearly 2 hours. I think that's probably about as much as I can show with this Bitwig thing, because as I said, I've not really done very much with it yet. Some jankiness. Yeah, I mean, you can try increasing the latency maybe. No, I don't have a workflow with this. I've not even had any time to experiment with it yet. So that's kind of why I want to push it out to people to do stuff with, because I don't really have that much time anyway at the minute. But so yeah, you should be able to install it relatively easily from my library. And there's lots of different experiments I want to try. But I just haven't had the time yet. So yeah, I think that's probably all I would want to say about that for now. And I think if you explore in the library, you'll see kind of like how I've structured it in a way that means it's really easy to add more targets. So if you have other things that you're controlling with Tidal, all you need to do is like make the target file, and then at the end you just need to have an output OSC map, and then you just add that to your list of targets, and then you can just kind of like comment or uncomment them depending on what you're doing. But the cool thing again is that if you have multiple ones enabled, you can do them all at the same time from the same pattern, which is just like kind of just really insane. So yeah, so there's two. Oh yeah, so I've got so how many people are still? There's still 17 people here. That's really amazing. So for you people, I have a special treat, and that is a thing that I've been working on with David Alexander of Toybox Audio. So I don't know, yeah, if you've seen some of my like posts from last year, you might have noticed that I did this thing with David from Toybox. So Toybox is like a reactor blocks thing, and it's like a block collection, over 200 blocks, and just really crazy stuff that you can do in reactor. So me and David made like this thing called Live Core, and basically it is so if you know anything about reactor, basically there's a low-level DSP environment in reactor that you can kind of do live in a sense, because it recompiles live without glitching the audio. And so David made basically a library that allows you to do like live coding inside Reactor. And so now that we've got this new Tidal integration with the OSC, we've written an OSC spec for Reactor, and this is it. So that is also in my library right now. So if I just launch Reactor and change my Tidal boot, where is it, to the live core OSC map, and then I have some examples here. Just need to kill that and quit subclutter. So I think this one was okay to work with. Right, so basically this one I think should work. Oh, I need to change the output device. Yeah, it should work. Oh, there it goes. So basically, what you have is this massive library of small modules called nano. David calls them nano pack, and there's just hundreds of these modules. And basically, these OSC notes and control are designed specifically for Tidal input. So for the note OSC, you have like channel expression, all sorts of stuff, and you have a control input. And again, these are just coming directly from this OSC spec. So you've got note, control, you've got a sampler. So this thing even works with like Striate, and all of the Tidal like granular functions all work with this as well, which is just mental. And there's this block called select down here, which is kind of like a matrix block, which means that you can kind of like hook up the matrix block, the selector, and then you can reroute this block from Tidal. So you can basically you can almost like patch from Tidal using this selector matrix. So yeah, and because it's Reactor and it's all like low level optimized stuff, you can just do some really nuts things in here. And so I just wanted to show a little bit of a preview of that. If you want to try the beta, then go to look up Toybox Audio and get in touch. And David says he'll send you the beta. He's not sure how he's going to release it yet. But yeah, that's getting ready to be released soon. Yeah, so that's just something I want to show. Random, but what's the key to restart Haskell Tidal from your editor? In Emacs, it's Control C, Control Q. So if I go to Tidal.el, this is the Emacs thing, and that's all the keyboard shortcuts, I think. So let's quit CQ. So yeah, if you know Reactor, then you really need to try this. There's some more demo code and stuff. But yeah, again, we've only just got this set up, so we also haven't done that much experimentation yet, but that's something to look at. So the last thing I wanted to show, I think, and then I'm probably going to like collapse, is my Tidal library. And so yeah, that basically just came about from years of just like saving snippets and then figuring out a way to kind of organize them. So maybe what I'll do just to make it easier to look at is window with just that in there. So yeah, there's some instructions about how to use it, but they may be slightly out of date. So if you try and use it and you have some trouble, then just let me know. But yeah, so there's some supercollider stuff in there that I showed right at the beginning of this stream. Some random bits and bobs that you might find useful. Some Bella stuff. Yeah, there's not that much. I don't have like super synths or anything like that in there at the moment because that stuff's still really messy. But I think the cool bit is obviously the OSC targets that I've already just been talking about. The stream stuff is now like really modularized, which I find really useful to be able to read the code. And then the actual kind of library itself is in this lib folder. So if you look in lib, you can see which ones are imported. And yeah, basically, I haven't really found a good way to do this yet, but you need to replace these paths with your like local path. So you can do like a find and replace on the whole folder and just replace path to here with whatever your path is. And yeah, I mean, the reason for that is that if I did it as a Haskell module, I would need to recompile it every time I made a change, but I change it like really often. So like I might if I'm developing like an OSC spec, I might change it like hundreds of times in a session, and I just can't bother to recompile it. So by using this script thing, I can just import the code directly into the interpreter, and I can, yeah, it's more like just scripting. What's a stream? A stream is, so if we go to like the Tidal GitHub and look at the default boot file, so this is what you get if you start, just from the main repo. So this is where we're creating the stream, and so the stream is just like the stream of events that Tidal is sending out. So if you look at the arguments for that, then you'll see that it's taking a target, as we've been discussing, and a config, and then there's this function start Tidal, which kind of boots the whole Tidal process, and it basically returns that process output into this Tidal. It's called Tidal, but it's just a variable name for a stream. And then all of the shortcuts that you have in your Tidal workspace, like D1 and so on, are defined here, and like mute and unmute and once and so on. So those are just like operations that you do to the stream. So the main thing here is that you have P equals stream replace Tidal, and then that means that instead of writing every time you want to write a pattern doing stream replace Tidal number $SBD or whatever, you can just do these shortcuts for like different like stream channels. And again, these are all kind of custom stream functions that have shortcuts, and then you've got transitions and so on. So yeah, you have one stream, but you might have multiple targets. now in the new Tidal. So yeah, so and again, I've just kind of modularized the stream so that it's a bit easier to read. And so in this library, it's kind of like a bunch of different stuff really for writing Tidal code. And so if I look at those in order, yeah, some of this is definitely down to like taste, obviously. But for me, I've used Tidal for so long that I just want things to be typed as quickly and succinctly as possible. So I have a lot of these shortcuts for the most common parameters. So you've got like orbit and fast. I never type fast. I just type FA and so on. And there's also some transition shortcuts as well. So I would never want to type jump in prime P2. I would just do J2 if I wanted to do jump into and so on. So that's some shorthands. I think it can be quite useful to write these. Signal, this is about kind of like shortcuts for doing like continuous functions. So yeah, you might have seen some of these in action in my code. But I guess you can think of them as like like LFOs or like modulation signals. And the way it works is there's just more parameters being added each time here. But what it means is like you can, like the most common one that I'll use is like R sin F. So basically that expands to that. Or maybe it's, and yeah, these are all in my boot file. So if you look in boot, you can see that this boot file launches the main scripts. So it loads targets, loads the stream, loads the lib. And then there's also target libs because some of the targets need to use the things defined in stream. So that just includes like stream related functions that also use a target. But basically it's like targets, stream, and then lib. And so yeah, I use these all the time. So it's kind of like a mnemonic that you learn to say like I literally say in my head when I read that ranged sign at frequency. So in that way you can easily remember that the R is always for range, and the middle is the type of function, and then the F is the frequency, or you could be fast, or it could be the speed. And just by doing that, it just makes it so much easier to use those. And then there's all these different variations of the same thing, but you don't need to remember every single one, because once you understand the pattern, you can easily remember what it does. So like Rx rand F means range exponential random at frequency and so on. So yeah, that was like a really important breakthrough for me. Tidal sequence. number sequences, these are really fun. And oh yeah, and I got Lizzie sent me these Fibonacci functions recently, which I haven't even tried yet, but those look really good for doing Fibonacci sequences. Odd and even numbers are really fun for doing like melodic stuff. So if you use, so it's basically a variation of run. So R odd means run of odd numbers. So run odd 8 would be, 1, 3, 5, 7, 9, and so on. But if you clamp those to a melodic scale with the scale function, yeah, you just get some really funny like melodic lines from that. And then the I variation, like ruddy, just means inverted, so it would be the other way around. So that's that. Param. Yeah, so these are like custom parameter groups. So instead of writing delay time, delay feedback, or tremolo rate, tremolo depth, you can just write tremolo like that using this group function. So with group, you use the colon as a list separator. So del for me controls all 3 delay parameters like that. And these can be patterns as well. There's some bugs, I think, with group at the minute. And then if you wanted one of these to be a function, then there are these variations below, which you can add functions to. So for example, I could just do that, and then now it would be this version, except I could change that for an LFO instead. So again, it's just really quick. Yeah, there's those pile and heap functions. I need to write some documentation for those, but they're really handy. So for example, so let's say if you do MIDI and you're doing control change numbers, you often have this kind of thing. CC where it's like the CC, the control change, the MIDI control change channel number, and then a pattern. And basically what this does is you can instead just write heap CC and then just have like that, and it's gonna auto increment the indexes. So that's just like a much easier way of writing like arrays of parameters where they're being indexed 0, 1, 2, 3, and then there's these variations. So heap prime, you add the starting index, so that would be the same as this. Bye, Alex. Good to see you on the stream. Thanks for watching. See you soon. And then finally, if you just wanted to have custom indexes, then there's a third variation. So yeah, if you do a lot of MIDI mapping or OSC mapping, then these are just really useful. Harmony. So yeah, this is pretty fun. So this is just all for one function, basically, harmonize. And so what it means is you can do something like this. And what it's going to do is go by Meisteru. Sorry, I don't know how to pronounce your username. Cool. Yeah, it looks like everyone's going to bed. Maybe I should do that as well soon. Basically, what this harmonize function does, it plays the chords from that key. So if you just played major chords from these numbers, obviously it wouldn't sound like they're in an actual key, because you know, if you're in C major, then the chords are, you know, D minor, E minor, F major, G major, A minor, B diminished. So if you play a D sharp major or a E major, then you're not really in the key of C major. So what this harmonize does is it uses these lookup tables to play the correct chord for that key. So here you can see there's major key, minor key. There's like, these are different modes basically. So you know, you can do Dorian and it will play the right chords from a Dorian key signature and a Dorian harmony and so on. So again, just really a really lazy way of doing like simple harmony. Like, you know, if you just want to have like a synth and you want to do like it's almost like doing power chords on a guitar, you know, you can just do like, you don't have to care about the harmony because it's just taken care of, and you'll have something that sounds like it's in a key. MIDI, I don't think I have anything useful there. MISC. Yeah, BPM shortcuts, just because I don't like, yeah, CPS. My brain learned BPM and didn't really learn CPS, so I just convert to BPM. Choose odd and even. If you, yeah, it's just like, it's like the choose function. So choose in Tidal will select a random number from that list. So choose odd will choose a random odd number from the first n numbers. So if I did choose odd 16, it would create a list of the first 16 odd numbers and then give me back a random one of those odd numbers. So yeah, kind of useful. screw. It's kind of a reference to like chop and screw, which is like a style of sampling. Just like a combination of loop and chop. Yeah, some other bits and bobs. Compatibility. That's just my stuff. Composition. This is like an experimental way of working with tracks in Tidal. I'm not sure if it's really any good, to be honest. I was using it for a while. I'll show you what a track looks like written in this style. Looks like this. So you have a do block with and it's kind of, yeah, if you've ever tried to use the function it's kind of like an extension of that idea, but trying to be more tailored towards making tracks. So you have an array of patterns which have a lookup name, and then you have an array of functions that also have like an ID, and then you have a mixer, and then basically what you can do is like mute and unmute tracks really easily. And so you have this function called track, and it has all these arguments basically of like the track name and the mixer, and then the track number, and then you pass it the patterns, and then the pattern that should be played, and so on. And yeah, it was kind of an experiment. The thing that's good about it is that because you pass it a track name, it gives each pattern a unique ID. So if you do so in the default boot title, you have this stream list. It's going to list you every pattern that's active by name. So often when you're doing like live performance, you might have two tracks that you're trying to transition between, and they might have patterns which have the same name in them. So what this does is it just prefixes the track title. So if you did track list, that's what you would see. It just means that you don't accidentally mute patterns from other tracks. So in the end, this was way too complicated, but I did get the mixer idea from doing this. So you can easily switch the gain of each track. So that was kind of useful, but that's there anyway. It's pretty messy code. I think that's it. I think that's all of my library stuff. And I guess the point as well is that it's really easy to add more stuff to it. So yeah, if you have custom functions that you like, you can easily add those in. So I think that's probably, yeah, 2.5 hours. That's probably enough. But there's still some people here, so I don't know if anyone has any questions before we bring this to an end. You are welcome. Abalone 1969. Can we play some more? I'm really tired. I'll try and do a more of a musical stream sometime soon. Hopefully. When I've played around with the Spitwig stuff, that would be a good time to do some more music. But yeah, thanks for watching. Hope it was useful. Sorry, it was a bit of a mess, but hopefully there's some good stuff in there that you can go back through the video and take some ideas from. So yes, enjoy Tidal Club. Thanks everyone for supporting Tidal, and yeah, keep sharing your stuff in the Tidal Club because there's some really nice patterns and functions being shared there. Okay, good night everyone, wherever you are in the world. Stay safe.